at right now is a definition of the alternating series test, or AST for short. The AST is one of many tests to determine whether a series converges or diverges. Whoa. That was a mouthful, so let's start from the beginning and work our way up. A sequence is a list of numbers in order. For example, what you're seeing on the screen right now, 3, 5, 7, 9, and so on, is a sequence. Listing out all the numbers of a sequence in order is tedious, so we often represent sequences with a formula instead. For example, this sequence would be represented with a formula that the nth term, often they refer to as a sub n, would equal 2n plus 1. A series, on the other hand, is the sum of the numbers in a sequence up to a certain point. The symbol on the screen means sum, or sigma, and it represents the sum from the first term up to the nth term of the sequence. A series is often represented as a sequence of partial sums. Here, that's a little confusing, so let's work on an example. Let's find the fourth term of the sequence of partial sums of the sequence we looked at before. Wow, that was a mouthful. But all that really means is to sum the first four terms up of the sequence we looked at before. For that sequence, which started with 3, 5, 7, 9, remember we found its formula to be 2n plus 1? Well, all we're doing is we're summing up the first four terms of that sequence. This is just equal to 3 plus 5 plus 7 plus 9, which is 24. See, not so bad. As we build up to the AST, what we want to do is we want to see how do series look like as they tend towards infinity. In other words, as you sum more and more terms, what happens to the series? Now there are three options for this. 1. The series can converge on a number, where we say it converges. 2. The series can blow up towards infinity, we say it diverges. And 3. The series oscillates between two numbers over and over again. We also say the series diverges there. As an example, let's look at the series of reciprocals of powers of 2. In other words, 1/2 plus 1/4 plus 1/8, on and on and on. As you add more and more terms, the value of the series gets closer and closer to 1. Thus, we say this series converges to 1. The alternating series test deals with infinite series whose terms that they sum alternate between positive and negative. In mathematical terms, this is represented by the sum of -1 to the n times a positive sequence. This is because -1 to the n alternates between -1 and 1, and thus the terms of the sequence that you're summing will alternate between positive and negative. Now, for the rest of this video, when I refer to the sequence, I'm referring to the positive part of the sequence that's multiplied by -1 to the n. In order for our series to converge, we first of all want the terms of the sequence to tend towards 0. Let's say they tend towards some number that wasn't 0. Then you would always be summing some term that's greater than 0, which would obviously blow up to infinity. Thus, we need the terms of the sequence to tend towards 0. This is actually a pretty general result, and it's often referred to as the nth term test. And the last condition we need to check to apply the alternating series test is that the sequence is decreasing. Now, let me show you why, if the sequence converges to 0, is positive, and is decreasing, that the series must converge. Let's take the alternating harmonic series, or 1 minus 1/2 plus 1/3 minus 1/4, on and on, as an example. I'll claim that this series has to converge to something less than 1. Now I'm about to show you why. Take a look at the part that I've circled in red. It's clearly negative, because -1/2 is the biggest term, and smaller terms alternate from there. Additionally, its magnitude is also clearly less than the first terms. Since the series is decreasing, that means we know it hones in on a number. And since the red part is less than the first term, but negative, we know that the series converges to a value in between 0 and the first term. And that's it, that's the alternating series test. If the magnitude of the terms in the alternating series are decreasing and converge to 0, then the alternating series converges. Thanks for watching.